Hello everyone. We are solving question number 44 of GATE 2013 Chemical Engineering paper from the subject related to instrumentation and process control. The question is, a unit gain second order underdamped process has a period of oscillation 1 second and decay ratio 0.25. The transfer function of the process is dash. So in this given question we have been given a second order process, and then we have been given few of these features such as this period of oscillation, decay ratio, and we have been asked to write down the transfer function using the information that has been provided. So in this given question we have been given, the first thing we have been provided is the unit gain. So the gain we can write it as kp, and here we have been given it as 1. Then we have been given a second order underdamped process, that is second order system. Now, in general, the transfer function of a second order can be written as g of x, that is basically in output y of s upon input x of s, that can be written as kp tau square s square plus 2 zeta tau s plus 1. So here kp is the process gain, tau is the time constant, and zeta is the damping factor. Now other thing that we have been provided are this period of oscillation is 1 second. So we can denote the period of oscillation as t, and it is 1 second. Similarly, we have been given decay ratio as 0.25. Decay ratio is 0.25. Let's just call it as dr is equal to 0.25. Now the formula for decay ratio will be, these formulas we need to remember, so that can be found out by solving this equation, the finding the output equation, and then plotting it. Then of that plot between y of x, that is the set point, and the actual output that has been measured, we can find out the features related, and we can find out this decay ratio, period of oscillations. So from that plot we can find out that the decay ratio is basically exponential of minus of 2 pi zeta upon under root of 1 minus zeta square. So in this case we have been given this as 0.25. So we can take log on both the side of this equation, and then we will be having minus of 2 pi zeta upon under root of 1 minus zeta square is equal to ln of 0.25. So basically we want to find this value of tau and zeta from which we can get the original transfer function. So from decay ratio we can find this value of damping factor, that is zeta. So we can solve that equation. So ln of 0.25 will be 1.3863 is equal to, on the right hand side we were having, so we will be having 2 pi zeta upon under root of 1 minus zeta square. So ln of 0.25 was minus of this, and over here also we were having minus, so that minus gets cancelled. And so on solving this, we can get 1.22. So we are taking square of this, it will become 4 pi square zeta square upon 1 minus of zeta square From here we will bring 4 pi square zeta square is equal to 1.922 1.922 minus of 1.922 zeta square, and on solving this we can get the value of zeta as 0.2154. Now the other parameter in the question that we have been provided is the time period of oscillation, so that we had been given as 1, so p is 1 second. The formula for time period of oscillation is 2 pi tau upon under root of 1 minus zeta square. So from here we can get the value of tau, that is a time constant. So we can replace the values 1 upon 2 pi upon under root of 1 minus of 0.2154 square into tau. So this will become, from over here we will be getting the value of time constant as 0.1554. So now we are having the value of tau and zeta that we can put into this, put the value of tau and zeta onto the transfer functions equation. So the transfer function equation was g of s is equal to kp upon tau square s square plus 2 zeta tau s plus 1, and now we can replace all these values. So kp was 1, tau we had found out to be 1.1154 whole square, s square plus 2 into point, the value of zeta was 2154 from the earlier slide, 0.2154 into 0.1554 s plus 1. So this can be written as 0.024 s square plus 0.067 s plus 1. So this is the transfer function of the process that we have been provided. So over here you can see that the value of zeta that has been obtained is 0.2154, that is less than 1. And also in the given question we have been given that the process is underdamped. So from that you can see that you are going in the right direction. So is the final answer of this question, that is to find the transfer function, is option A.